Friends, we shall continue limits in the same exercise. It's number 30. If f of x is equal to modulus x plus 1 for x less than 0 and 0 if x equals 0 and modulus x minus 1 if x greater than 0, for what value or values of a does limit x tends to a exist? First we shall consider the case where a is a number less than 0. When a less than 0, limit x tends to a f of x equals, we take x equals a here, that is limit x tends to a modulus x plus 1, that is equal to a plus 1. Then when a greater than 0, if we consider a to be a number greater than 0, limit x tends to a f of x equals limit x tends to a modulus x minus 1, that is equal to a minus 1. Therefore, limit x tends to a f of x exists for all a less than 0 and a greater than 0. We have seen that the limit exists for all values of a when a is greater than 0 and a is less than 0. Now we shall consider limit at a equals 0. When a takes the value just below 0, what happens? This is limit x tends to 0 minus modulus x plus 1, that is equal to 1. Limit x tends to a plus f of x, that is limit x tends to 0 plus f of x, that is limit x tends to 0 plus when which is greater than 0, this is modulus x minus 1. That is equal to 0 minus 1, that is minus 1. Here left hand limit is equal to positive 1 and the right hand limit is equal to negative 1. LH limit at x equals a not equal to RH limit at x equals a. You have seen that limit at a equals 0 does not exist. Why? When that number a takes the value 0, limit extends to 0 minus, that is, when x approaches a equal to 0 from left of 0, the answer is 1, and that from right of 0 is, the answer is -1. Therefore, LH limit at x equals a not equal to RH limit at x equals a. Therefore, we can conclude that conclusion: for all values of a, limit exists for f other than a equals 0. The conclusion is, for all values of a, we can write other than 0. Other than zero limits exist. Once again, we tested a for a value less than 0. In that case, we got the limit a plus 1. We tested for a greater than 0. In that case, we got the limit a minus 1. Then we tested for a value equal to 0, for which limit extends to 0 minus was checked, and it was seen that limit extends to 0 minus f of x. Limit extends to a tends to 0 minus mod x plus 1 is 1, and limit extends to a plus f of x, that is, limit extends to 0 plus f of x is equal to limit extends to 0 plus modulus x minus 1. When taken the value was seen -1. That means LH limit, that is left hand limit, not equal to right hand limit for x equals a equals 0. And next takes the value a, which is at present 0. Left hand limit is not seen equal to right hand limit. Therefore, when x takes the value a, which is 0, will have no limit. So the conclusion is, for all values except a equals 0, the function has limit. Right.